Hi, welcome to Oahu, Hawaii. I'll be your realtor, Christina Lowe, and I'll show you around this place. When coming to Oahu, these are all the things that you will be able to see and have and explore on. If you decide to purchase this Hawaiian tropical island, you will expect great weather near the mid to high 70s year-round. Not to mention, you'll be in the heart of Hawaii, Honolulu. Honolulu is the most popular city in Hawaii. Many tourists come here when they think of Hawaii, so you should bid fast for this popular land. Oahu also provides vast amount of beach lands, and the water is extremely crystal blue. You'll also be able to scuba dive, surf, and interact with marine life such as turtles and fish like Dory and Nemo. When purchasing this land, you will own Oahu's most popular attractions. These include Waikiki Aquarium, Honolulu Zoo, Hanauma Bay, Oahu, Pearl Harbor Museum, and Ioannina Palace. Right here I divided the Oahu Island into triangles T1, T2, T3, and T4, where T stands for triangle and it's color-coded in pink. And I also labeled the sides S1 all the way through S10, which is the side length of each triangle. And I measured these lengths using a ruler, using inches, and you can see the measurements on the side in the white box where I measured it in inches. Also on the bottom left-hand corner of my map, as shown right here, I calculated the actual, what would be the actual length of each inch. So I calculated that 1 inch is equal to 15 kilometers by using my ruler. Now to calculate the actual length of each side of the divided triangles that I made on a real map on Google Maps, if it was like the real length, the real distance, I just timed however many inches that I measured from the previous slide, and then I times it by 15 kilometers to get the actual length of each side. And you can see my calculations shown on the right hand picture. Then after calculating the actual length of each side, we are then going to calculate the angle for each triangle. So each triangle that I made had 3 angles that are not given, but we are given 3 sides, so that means that we can use the law of cosine. And the equation of law of cosine for one type of it is cosine of angle C is equal to a squared plus b squared minus c squared divided by 2ab. And I use this formula to solve for most of all my angles. And so, for example, for the calculations for T1, which is triangle 1, which is shown right here, that triangle, and the calculation is right here for T1. I started off by solving for the blue angle as shown in the picture in triangle 1. That's why I color-coded each of the times I used the law of cosine. So when I first started calculating, I used cosine inverse of a plus b squared, which was side 1, and side 8, which were the 2 longer sides of the triangles, and then I subtracted it by the side that was straight across from the blue angle, and that's how I got 26.226 degrees. And I did the exact same thing with the green angle for the cosine inverse, which was side 2 plus side 8, which were both squared, minus side 1 squared over 2 times side 2 times side 8. And then lastly, to solve for the last angle, which was right here, since I already knew 2 of the angles, I just subtracted both of those angles from 180 because 3 angles in a triangle add up to 180. And so that's how I got 110.105 degrees. And so you can see from the rest of my work here that I did my work using law of cosine of c is equal to a squared plus b squared minus c squared over 2ab, and I color coded it with the corresponding angles in the picture shown right here, so that you can see what I was trying to do. I color coded the angles to match up with each of my work. However, for the calculations for triangle 2, I did do it one other way. I first used the law of cosine, which is shown above right here for the first angle, as what I was doing for my calculations in T1, triangle 1. But then for my, when I was finding the green angle, the second angle, which is right here, I did it using the law of sine. And the law of sine is corresponding side is divided by corresponding angle is equal to another corresponding side over corresponding angle. So for example, the equation would be side B over sine angle B is equal to side C over sine angle C. And then again, for solving for the last angle for triangle 2, I did again what I did in triangle 1. I just did 180 subtracted by the sum of the two angles I solved before that, because of the rule of how 3 angles equals 180 degrees in any triangle. And so for when solving triangle T3, T4, triangle 3 and 4, I did the exact same procedures as I did in T1, only using the law of cosine and then subtracting the sum of those two angles from 180 to find the third angle. And then that's how I solved for all the angles from the triangles that I made in this piece of land. Because I couldn't fit all the images of the calculations I did on one slide, here's the calculations of T1, T2 with my diagram that I drew right here that corresponds again what I said with the color coding of my equations and the angles in each triangle for T1, T2, and here are the calculations of the sides once again that I showed previously and a couple of slides earlier to show you the comparison of what exactly for each side number that I used in my equation. So if you want to pause the video to look further into my calculations, you can. And here again is another close-up of my calculations for triangle T and triangle 4. In case you didn't get a close enough look of my calculations before when I was explaining how I use law of cosine to solve for my angles, and then I subtracted both of the angles that I used with the law of cosine, subtracted from 180. And these are also again with the calculations of the sides shown right here in case you didn't get a chance to see the sides. And then after calculating for all the sides and all the angles of the triangles that I cut in, that I made from Oahu, I was then finally able to calculate the area of the region. And I did this by, again, individually solving for each area of each triangle, and then adding the sum of all 4 triangles together to find the total area. Now, the normal equation for a non-irregular triangle is base times height divided by 2, but since these are irregular triangles, you have to use the equation A equals 1/2 AB sine C, which is this equation right here. And so this equation is just saying that half of the adjacent and hypotenuse legs times sine of the angle across from length h, as what I drew, is equal to the area of a triangle. And so, to show you what I'm trying to say, for like what I saw for T1, I did A is equal to half of 37.5, which is the side length of side 1, times 51, which is the side length of side 8, times sine of 26.226, which is the blue angle as shown in the picture, which I took from our previous calculations of the angle. And so all those multiplied together would equal the area of that triangle, 422.579 kilometers squared. And so I did the exact same process as what I explained in T1 to in T2, T3, and T4. I did the exact same process. And so at the end, to find the total area, I just added the individual areas of all 4 triangles all together to get a total area of Oahu to be 1,847.193 kilometers squared. And you can have all this land for only $1 million per square kilometer. That's a total of only $1,847,193,000.